And there we go. Okay, so my task was to build a box, within a container. The box was supposed to have this small amount of text and be centered vertically and be aligned to the left in its container. So for that, I just set the container to flex direction column, then the aligned items to the flex start, and justify the content to the center. This is great. But then, after some user interaction, I want the box to move to the center. That's very easy to do with flex. Again, we just switch the align items to center. And then, but then what I wanted to do is to have this actually moving slowly from the left into the center. I didn't want this box to jump. That didn't look nice enough. So I wanted to have an actual animation that went there. And to do that, I can no longer use the flex start. Okay, I lost that. The web didn't help me with that. But I can still use the translate X property. So I can start at the start. It should say align items left as well, but never mind that. I can start with a transform that sets the translate X to 0. And then I move it to somewhere. Question mark, because I don't yet know where should I move it to. And when I'm going to figure out where I should move it, I can do some calculations. So now I no longer can rely on CSS to do the magic for me. So I need to measure what the container width is going to be, which is okay. It's the window, so you can do window.innerWidth. It's fine, we know that. And then if I just can know the size of this actual box, the element width, I can take the container width, take the difference with the element width, divide by 2, and that's the displacement that I should do. The problem, though, is that I cannot know this element width. This has text inside. The size of the container is set by the text, and I just can't make this happen. So I'm going to talk about deterministic rendering motion, and what I think myself, it's the future of styling, or should be the future of styling. So first, I wanted to give a shout out to the foundation that we set up with Leandro. He already mentioned that, so I'm going to spare you the pain. And he spoke in JSConf recently in Berlin, and we host the recent Stockholm meetup. But what I'm going to talk about today is more related to my day job at Klarna. So I'm part of the design system team at Klarna, and that's fancy for the UI toolkit team. We do React components that everybody at Klarna can reuse, and they can compose together to build the products. So it's a React library, really, and we work together with the designers on that. And the reason I mention this is because this allows us to focus on actually improving the implementation to what the designers want us to do, including moving things, including making them pixel perfect. So we actually have the time to dedicate into exploring this kind of problems. So the exercise we're going to go through, it's a small application in which we have, I wonder if that's too small now, but it doesn't matter. We're going to have some person cards on the left, which is just a list of all the people. And on the right, we're going to have a small list of the favorite ones. And we want to add functionality to this application in which you can move some from the list of the all to the favorite ones. And this is how the code for that looks like. I'm assuming React in here. It really doesn't matter. It's just that this allows me to represent this in the code. And in this case, we have a wrapper for all that has a list of persons, and another wrapper for the favorite ones. So we're going to try to move Albert Einstein to the favorite ones, because it's everybody's favorite. And the first thing that we do is to select Albert. And we added that functionality to this application. And after that, we allow the user to press the key 2 to put it as the second favorite person in the right. And that moves Albert to the right. And finally, the list moves up to fill the gap. So this is good, but without any motion, without any transition between the two positions, can you see really if I was not highlighting it? Can you really see what happened from here to here? So it's very hard to see that something moved on the right, sure, and you see that some card was probably added, but tracking what card individually, it's very hard. Actually, if you look closely, not only I moved Marie Curie instead of Albert, but also I moved Albert Einstein inside the left one. It's very easy to miss. I mean, this is what magicians do to confuse you. So what we really want to do instead is to represent this with an actual visual motion and animation to guide the user to let them know what's actually happening. The first step for that is to move displace the elements on the right column, on the favorites column. We want to move them down to take them away from the place that we want to fill. The second thing we want to do is to move the card from Albert Einstein into the favorites column. And finally, we want to move the bottom cards to fill the gap. So this is a chain animation. It can also happen in parallel. You can decide exactly how to play it. But for actually making it possible, again, as with the initial example, it's no longer as simple as to say, okay, place this card here in this flex flow. Now you actually have to measure where the card is going to be. Sorry, this is dumb slide. You measure where the card is going to be from the left at the origin. You also need to measure where it's going to be from the top when it starts. And out of order. So we start by measuring where the card is going to start to be, and we're going to, at some point, measure where the card is going to end up. We're going to focus on the motion of the card itself, not the opening the space and closing up the space. So what we need to do here is to find out what the distance from the left from the window start to the card it is on the left, and what the distance from the top to the start of the box is on the top. And to do that, we need to know the dimensions of the card, because we are going to measure the card. It is centered within the column of all, so we need to find out where it is placed. We can know the size of all. We need to find out what the displacement is from the left inside that box. So the first thing that we need to know is the card size. And we do, because this comes from the design. It is set in stone that these are the sizes of the card. And we know the width of the card, we know the height of the card, and we also know the size of the padding between each of the cards. This is very useful because when we want to measure the displacements from the left, we just need to take the size of the all container, take the difference, subtract from it the width of the card, and then divide that by 2. And we know all of these things, so we can do it. When we start from the top, we need to know the distance from the header, which is set by the designer. They told us it should be 70 pixels or whatever. And add to that the size of the card plus the spacer times the amount of cards that we have before this one. So it's a bit of math in there, but we know all these things. We know the size, the height of the card, and we know the distance from the top. For the target position that we're going to aim at, it is very similar. We also need to measure the size, the distance from the left and the distance from the top. And in order to do that, for the left distance, we need to know the width of this favorites column, and we need to add to the distance. We need to get the distance from this favorite width with the card width divided by 2, and add the width of the left column to it. And finally, we can get the distance from the top, which is the same calculation as the original one. Cool. So, okay, that was a bit of a ride, but we can know all that information, so we can actually do that motion. There is still a problem, though. By the end of our animation, our Albert Einstein card is still placed in the original collection, because we moved it visually, but logically, it was never moved to the favorites collection. So we change the top and the left in the code. We displace it. It looks very nice. But it's still contained within the left column, logically speaking. So at some point during this motion, we need to change it from this wrapper here to this wrapper here, so that it ends on in the favorites list. But when? So usually this is done either at the start or at the end. Either way, you need to calculate the length that the motion will take in time to know when is the time to switch. Otherwise, it will jump. This adds an extra layer of complexity. And you can avoid that complexity. And one thing that can happen to you is that you're actually doing this motion through more containers. So what happens if you have a search result list as well? Like, the complexity of this is going to grow very rapidly. So what you can do instead, and what is very tempting to do, is to group all the people in just one list and just have fake backgrounds for the placement. So you actually move them visually, and in your database you know where they actually are, but you never change them in the DOM node. Okay, so we can do this. It works, and it gets placed properly. Everything is in the same wrapper. But was all of that complexity necessary? Was all that struggle something that we really had to do? Is there no easier way to do this? So what I'm going to go through here is a bit of background on why this is so complex. So there is a picture of the schematic of the Large Hadron Collider. And the reason I put that there is because that's where the web was born. And that's what for the web was born. Like, Tim Berners-Lee invented that at CERN. And the goal that he had in mind was sharing scientific papers, not doing motion between columns. This shows, and I'm going to maybe bring something to mind that maybe it's always in the background, but it's easy to forget. So you have a document like that, and before the existence of the web or LaTeX or any kind of digital format for papers, the hierarchy in a document like this one was represented by the visual styling. But once you have some kind of digital format of it, you can extract metadata about it, like a table of contents. So now you have the structure represented already in the code. So this is what the web was born to do: structure documents, structure document-like formats. Another thing that the web was born to do is to turn this really hard to follow things, turn them into resources that you can locate unequivocally in a computer network. And those are the URLs. And that is incorporated into HTML. So now everything is linked together. And when before your process for research was going from a paper to another paper to another paper, hopefully in the same library, after that it's just going through a flow of different screens. And the history of your work is left in the history tab of your browser. So the web made explicit the structure that was implicit before. Books have always been interlinked. The process of researching through them has always been this process of jumping around. The web just make it explicit. What this means, however, I think it's here, so that the structures of visual representations that are based on documents are optimal in the web. They work fantastically because it was designed from the ground up to be like that. But it also means that the natural flow of a user experience in the web is screen by screen. So you're in a screen, you can scroll, maybe. You can maybe go to a section, but really what you do is click a link and go to another screen. This is how the experience in the web works like. What this also means, however, and unfortunately, is that other experiences are far from optimal. And sure, over time, there has been a lot of improvement. I was talking with somebody here before about how video now is way less painful as it was before. But it still feels like an embed, like something that was added on top of the web. I would say that the only success story that we have of a technology really being adapted for the web is SVG. But other types of media feel a bit forced in. And it's very easy to take for granted things that the web does automatically for us. So one of those, for example, is that the web is very good at placing text. So you can place text on the web. That's not something that you can do in all graphical platforms out of the blue. Most of them, like if you go to gaming platforms or to like 2D rendering engines, is mostly you can draw rectangles and things like that. Font rendering is actually very hard. And one of the things that the web does automatically that most engines don't do is make the text flow when it hits the border. So most engines would actually do this. So the web is actually automatically responsive because it grows to the size of your window and then it flows. Another thing that the web does that it's not automatic is that it wraps a container around your text, and that container is a box that will displace any other box that you put next to it to be below or above. You can do styling on top of this and change that behavior, but this behavior is also not something that is to be taken for granted. Most engines will simply place it at top 0, left 0 at the start of the view. And even after that, if you put more content, what will happen if the content exceeds the size of the window, it will not just get clipped, it will also open a scroll bar. So this is a massive amount of assumptions about what the experience should look like and how the experience should feel. And CSS is only tweaking this. Like we have the feeling that CSS gives us the power to fully styled experience, but it's not really so. CSS is only on top of this, tweaking it a bit, sometimes a lot, but many times not enough to get radically away from this model. So the problem, like so far though, the argument has been, and it's an argument that I sympathize a lot with, is that you should play along with what the web gives you. So try to write semantic HTML, try to write something that is optimized for screen readers, that is accessible, try to write something that will be optimized for search engines automatically. And that is really, really good. But there is a problem for it depending on what you're trying to build. So when you do a screen-by-screen flow like this one, clicking a link automatically causes the browser to reload, which is a massive thing. Everything changes, the screen gets white, like you can really feel that something happened. But when you're doing micro interactions within a flow, within a window without reloading completely, it's very easy to miss that something happened, as I wanted to illustrate with the card switching. So you really need to rely on motion. The good thing about this is that the web actually provides a way to do motion. It provides 4 natural ways of rotating, displacing, scaling, and making more or less transparent things that are optimized by the GPU. Because most of the motions that you can do in the web by animating elements are not going to be optimal since they imply DOM mutations. But these ones are accelerated. So it's actually possible. And we can try to employ this kind of motion to add to the language of the web. So this rant aside, we did manage to make the application move, and we managed to do the motion, right? So we had to pay a price for it, however. We had to switch everything to position absolute so we could display things. And we had to completely flatten the nested structure. We did gain the ability to move everything, so now we can really move things around just fine. And we gained the ability to control the layout with high precision. Instead of relying on Flexbox, on CSS Grid, which could have limitations, we can place elements as we see fit. But we did lose all semantic meaning of the markup, all CSS layout as a help. Like we cannot rely on CSS layouts anymore, and in my case. So we thought it was working. And then somebody asks that we do this. And this is an eyesore, so why would somebody ask to do this? But sometimes they ask us crazy things. What is happening here is that the cards no longer have a width of their own. Instead, they are relying on their content to get the width. So we need to do the calculation knowing the width of the card that we had like this, but we no longer know the width. So it no longer works. And this is the problem that I want to address with the deterministic rendering topic. Box sizes for the text are not predictable with current web APIs. So, and we actually did this. We actually did solve this problem to some extent in my team. We did it with a combination, not a technology, but a combination of another two technologies I'm going to mention. So there are some ways of containing this problem. But all of them have problems. So for the first one is, if you happen to have this scenario in which you have a card with some text and you want to measure it, you can use context to the measure text. So Canvas will actually give you an API to measure the text size. The problem, however, is that it doesn't do line folding, because, as I said, line folding is not something that is given. So the Canvas API just renders text and keeps rendering forever. You need to do the measuring and the line folding yourself. So it's not particularly useful, since you need to redo what the browser was doing for you. The other thing that you can use if you're using React is the use layout effect. This allows you to synchronously get the DOM element that you're trying to render, and then you can measure it. And you can check the width, you can check the width in the bounding box, and use that to re-render, this time taking into consideration that box. The problem is that this only works for the first render. If you, for example, resize your browser window, and suddenly you have 2 lines of text because it didn't fit before, you will not get notified. So you need to complement this with the resize observer. And the resize observer will inform you when you got a new size for your component, so you can remeasure everything. The problem is that it's unreliable as fuck. Like, we are using it, it's not great. But there is another more fundamental problem with this. Like, I want to highlight, this is the current state. You cannot get away from something like this if you want to do motion with dynamic objects that can have whatever text. And there is a big problem with that. So let's say that we want to have this simple interface that just matches the height of the boxes. And I know you can do this with tables, you can do this with CSS Grid. There are many ways of doing it. Just bear with me that we just happen to have to do it with this approach, for example, because we want to do it with emotion. So the first step that you need to do is to render both of the boxes with their own text content. Then the next thing you need to do is to measure them. So you measure them, you're going to try to make them both of equal height, and you check the height of the first one, the height of the second one, you get the max one, like the maximum of the two, and you're going to use that to re-render them with that, like the bigger height. This is great. The problem is that once you re-render, you need to remeasure, because you don't know, since it's not deterministic, there is no way to know what the browser is going to do unless you measure. You need to check that you actually got to a point that the height that you got is really the maximum height in the screen. What could happen, for example, is that the text that you have got affected by the change that you did, and something grew. And the problem is that you can run into race conditions, you can run into infinite loops very easily. So I think that it's very easy to miss in this context how big the difference of just rendering versus rendering, measuring, and re-rendering is. It's a massive difference. It's a complete game changer if we were able to just render once. For context, this is what a function that you just do once looks like. This is a function that doesn't fit into itself. It's just a random example of a polynomial. It doesn't matter. But this is the type of functions that you get when you just get a variable and you get an output from it. And this is what happens when you feed into itself. Like, I know this is a bit factitious, I think is the word, but it's not just for the flash. It's actually the fact that chaotic things happen because of self-referential processes. So the moment that you render and then measure what you just render and then re-render based on your measure, you open up these kind of worms where you could be in this world. So, and this is the limit of CSS. This is my contention, that CSS has a limit and we reached it. And I don't think we can get past that fact. CSS can't know the text size, and by extension, it cannot know the content size. It cannot tell you what the container size is going to be. And CSS can't handle its own layout systems together with transitions. So even among itself is inconsistent in this sense. But the CSS killer, in my point of view as well, is the fact that nowadays we are commoditizing the parts of the browser and reusing it in other platforms. And I realize this is very small, so it might be hard to see, but it's a thread about using CSS transitions in React Native. There are no CSS transitions in React Native. Most of the CSS standard is redundant, so the React Native team just decided to remove all of it. Not all of it, but most of it. And there is a reason for that. As we move forward and try to reuse the concepts of styling that we have today in other platforms, we're going to get rid of the useless parts and transitions. Well, they are nice, but they are not the right approach to animation. There is another problem with CSS as an animation tool, is that CSS works with the DOM. And when you manipulate things of the DOM, you cause repaints. This is just a schematic of a typical repaint scenario that you can see with the React Dev tools, for example. You can highlight the re-renderings. I think you can do it in Firefox as well. And you're going to see that there is a lot extra happening that is not just the animation. And that will almost guarantee that you don't hit 60 frames per second, so it will look bad. And it will be extremely slow on some devices. So you're actually making your website less accessible and probably ruining the user experience for people in older computers. So the question is, should we give up? And this is my point. No. I mean, this is what I live for. Never. We should go all in. We should actually fix what was wrong in this approach. We should do all rendering to canvas. And I'm saying canvas, but you can search and replace with what Jonah suggested with the GLSL. So you could do use another GPU accelerated way of doing graphics. You could also use SVG if you're just caring about layouting and not to focus on a performance. And for the HTML itself, let's make a beautiful semantic tree that we don't render. We just have it there with display hidden or whatever, that it can be used for tabbing, for accessibility, for SEO, and so on. Like this that I show here, which is what I could wish I could possibly do in that example with the cards, is absolutely impossible if you try to do motion, because then you have to completely ruin your DOM tree. And yeah. Cool. So what is stopping us? Well, text is stopping us, as I mentioned. Let's take this as an opportunity. So text rendering in the web is broken in many other ways, and this is one of them. So this paper, Breaking Paragraphs into Lines, it's rather small, by Donald Knuth and Michael Plass. It's a paper from 1980, so it's quite old, almost 40 years, specifying an algorithm for folding lines into paragraphs that is far better than the one the browser uses. It's so superior. Unfortunately, as far as I know, only InDesign, Adobe InDesign, and LaTeX use it. And the rendering is so much nicer in them. But the browser doesn't give you any control over this. So if we're going to implement an algorithm for it going into Canvas, how about we use this one instead? Another massive problem that the rendering of text in the browser has is that the problem of baselines. So if you talk about with a designer about typography, this is how they think about typography alignment. They have a grid where the font sits. So that grid includes, sits at the bottom of the font, and you can see that the Y, for example, in there is falling below the grid. So this is not something that the browser will naturally do. What the browser will do is this. We'll put it in a box that is a complete black box. You have no idea how the font is positioned within that box. and then you will put those block boxes together. So when you try to space them, you space between the boxes, but the boxes are meaningless, visually speaking. You have no idea how they relate to the baseline. So what you end up is with this, completely misaligned from the baseline grid. And this is the main reason why websites don't look like the designs. Like, I'm not kidding here. Like, most designers have extremely powerful tools to align to the baselines, and we just cannot reproduce that unless we work really, really hard on it. So I'm not only crazy talking about this, though. This I want to highlight. I think the time for this idea has sort of come. So Houdini in CSS, the extension that they are working on, includes the possibility of creating your own properties for CSS, right, and attributes for CSS. And one of the suggestions is a font metrics API that will be incorporated into Canvas that will actually give you way more detail about the font information that you have today and be able to allow us to do these sort of calculations more easily. We can still do them, but we need to rely on JavaScript libraries to read the font information. Then in the potential of variable fonts, and this is from a design conference, there was a designer complaining precisely of what I said and mentioning Donald Knuth about the breaking lines into paragraphs. That is something that we need to fix in the web. It's a bit embarrassing that we have such beautiful fonts, ligatures, so many nice font features, but we cannot even break a paragraph into two columns because there is no way to know where the text is going to end. So we need to fix that. And just a shout out to Reverie UI, which is among many of the libraries that I've been seeing popping up lately, like Yoga from Facebook, that are trying to rethink layout in a way that is abstracted from the web. It's inspired in the web, and it uses many of the learnings, but it's not dependent on it. So in a way, this talk is kind of part two of a talk that I gave some time ago in Klarna about universal components. That talk was about trying to bridge the gap between the web and native. And that is to a big extent what motivates this kind of exploration. Because if we don't take the web as the final platform, then we realize that so much of CSS is pointless and redundant, and so much we could improve on top of it. So this is what I would like to end up with. The visual representation is a pure function of your application state. So while we wait for a solution from the standard community, let's solve this in userland. There is precedent for this. Before we had query selector, we had jQuery, exploring the patterns that they will eventually get into the APIs of the browser. Before we had WebAssembly, somebody built ASM.js. They were concerned with that problem, and they tried to solve it on their own, and now we actually have it in the browsers. And when Flash was eventually killed, they tried to replace it with HTML5 extensions, with video and audio and many other things, and that was great. But if Flash never existed, it's very hard to know how good that have happened exactly. So W3C will catch up eventually. Thank you.